This problem says that we have a 350 milliliter sample of helium collected at 22 degrees Celsius and 99.3 kPa. What volume would this gas occupy at STP, which stands for standard temperature and pressure? So we always start by writing down what we know. Our V1 is 350 milliliters. Our T1 is 22 degrees Celsius, and we know we're going to have to convert that into Kelvin. So when we add our 273, we get 295, and our P1 is 99.3 kPa. You're asked to find this volume, and you're told standard temperature and pressure. So standard temperature in Kelvin is 273, and standard pressure, and you have several ones, but I need the one in kPa, is 101.3 kPa. So because we have three variables, we're going to use the combined gas law. And it's called the combined gas law because it's Boyle's, Charles, and Gay-Lussac's law all put together. So we have P1, V1 over T1, and P2, V2 over T2. So we're trying to get V2 by itself. We're going to multiply both sides by T2. And I'll show out all these steps. So P1, V1, T2. And then you're going to divide both sides by P2. So we get V2, P1, V1, T2, T1 times P2. That should be a 1 there. So we're just going to plug into this equation. So V2 equals 99.3 kPa. I know it seems like a lot of work, but if you write these units out, you will make sure that you're doing it right. It'll help you see if you need to convert units or if you're doing the math incorrectly, because they won't cancel out to get what you need. T2 is 273. And T1, 95K times 101.3 kPa. And you can see in terms of units that Kelvin and kilopascal cancel out, which gives us milliliter, which makes sense for a volume. And since we're running out of space a little bit, we'll put our answer here. So now we do 99.3 times 350 times 273 divided by 295 divided by 101.3. And your calculator should say 317.503. And when we look at significant figures, we have 2, 3, 3, 3, and 4. So when we round our answer to have two significant figures, we get 320 milliliters. If you remember the combined gas law, you could actually have used this to solve any of the problems we've solved thus far. You just drop the units that are remaining constant. Several of our examples would say volume remained constant. Well, then you drop V1 and V2. Let's look at another example. This example says, if I initially have a gas at a pressure of 12 atm, a volume of 23 liters, and a temperature of 200 K, and then I raise the pressure to 14 atmospheres and increase the temperature to 300 Kelvin, what is the new volume of the gas? So we start by writing down what we know. So P1 is equal to 12.0 atmosphere, and V1 is 23 liters. And it's okay that this is in liters instead of milliliters. It just means our answer will be in liters. And T1 is 200 Kelvin. The new pressure is 14 atmospheres. We're asked to find the new volume, and the new temperature is 300 Kelvin. So our combined gas loss is P1 V1 over T1, P2 V2 over T2. So in order to solve for V2, we're going to multiply both sides by T2 and divide both by P. So we get V2 equals P1 V1 T2 over T1 times P2. So when we plug into our equation, we get 12 ATM times 23 liters times 300 Kelvin divided by 200 Kelvin times 14 ATM. And our atmospheres and our Kelvin cancel out to give us liters for our volume, which is good. We do 12 times 23 times 300 divided by 200 and divided by 14. And you get 29.5714. When we think about significant figures, we have 3, 2, 4, 2, and that should be 4 because there should be a 0 there. So we're going to round our answer to have 2 significant figures. The problem is that the 0.5 rounds it up to 30, so we either have to write it like this, or we have to write it like this. I will accept it either way.